Okay, this is the last portion of the third lecture on thermodynamics, the non-standard states. The thing about reactions is that when you start the reactions, you don't have them yet at equilibrium. And the fact that the reaction is taking place is simply a corollary of the fact that you're having reactants and products try to move over to the product side and to reach equilibrium, right? So that's that's happening. So when you start a reaction, the reaction is not at the standard state because you're not yet dealing with equilibrium. And to make that correction, we have a term that's very similar, RT ln of Q, added to delta G naught. And the one thing about delta G naught is that it itself equals negative RT ln of K. So if you were to combine these logs together, you'll find out that RT times the ln of Q over K has to equal delta G at the non-standard conditions. And thinking about it, what this tells you is that if K is greater than Q, well, the value inside the log will be less than 1. And anytime that you take a natural log of something less than 1, you get a negative value. So your delta G, yes, will end up being negative. And whenever delta G is negative, you have a spontaneous process. And what that technically means is that you will go from reactant to product side. In other words, you will shift the reaction to the product side. This will be a product favor reaction. And guess what? This is literally what the Chatelier's principle told us before. If K is greater than Q, then we expect the reaction to shift to the product side. On the other hand, if K is less than Q, then that means that Q over K will end up being larger than 1. The ln of a number greater than 1 will be positive, and that means that delta G will end up being positive, which means that the reaction will not be spontaneous, which in other words means that you will not shift from reactants to products, you instead will shift towards the reactant side. And so this is the mathematical format of the Chatelier's principle. And it's something that oftentimes in textbooks is completely bypassed or completely ignored. I think it's kind of important because it brings the full link of equilibrium in terms of how you go to the product side or to the reactant side in terms of favoring one over the other from the point of view of the delta G value. So this is the thermodynamic derivation of Le Chatelier's principle. All right, now let's do some examples to see what we actually do with them. This kind of brings us back to our equilibrium chapter, right, where we were looking at the value of QC to find out how the equilibrium was shifting. All right, so here we found QC equals 1, the KC was equal to 51, right? So we could actually determine, first of all, the value of delta G naught for this reaction, which is negative RT ln of 51. And we're going to assume the temperature is 298, although in homeworks, I will probably tell you what the temperature is. Okay, so we have 8.3145 multiplied by 298 times the ln of 51. And altogether, this is equal to negative 9742 joules per mole, which if you divide by 1000, you get negative 9.74 kilojoules per mole. Okay, that's delta G naught. Now, delta G itself is going to equal delta G naught plus RT of ln Q. ln Q is the same thing as ln of 1, and the ln of 1 is the same thing as 0. So, delta G in this particular case happens to equal delta G naught. And the fact that delta G without a naught is less than 0 means that the reaction is spontaneous and it will shift to the product side. So it doesn't really matter how delta G compares to delta G naught. All that matters is whether it's positive or negative. If it's positive, this will tell you that the reaction is reactant favor and it will not move to the right side. But if delta G without a naught is less than 0, then this will tell you that the reaction is spontaneous and it will shift to the product side. Okay, so with all that being said, that's a quick little example, but hopefully shows you, what you can do to determine the value of delta G and ultimately what you can say about the shifting of the equilibrium from the point of view of thermodynamic parameters. And with that last point, we have finished the thermodynamics lecture. What's left to be done is now electrochemistry. And granted, within electrochemistry, you'll find out that there is plenty of thermodynamics that also makes an appearance. So, good things to come. See you on the next video.